Okay, networking in the Windows 7 world, and this includes more than like putting IP addresses on. Some of this stuff we'll be able to go through relatively quickly because of the networking classes. Some of it we're going to slow down a little bit. When they start talking about firewall configuration, they're going to have you do a couple of firewall configurations in these activities, which is something that you should know. You'll get, again, a course where we spend about 2 weeks doing firewall configurations, writing firewall rules. Say again? Is that the security class that we have? That's one of the security classes, yeah. I'd say that. Different programs have different security classes. So if you're not a programmer who gets that one, get in the other program. See? And then you'll get more classes. Understand the Windows 7 network components. Nothing magic about that. What do you think the Windows 7 network components are? What are the network components, for real? What do you got to have to communicate on the network? A router? An NIC, a NIC. An address.
Not a NIC card, a NIC.
A lot of the NIC functionality now is not a separate card. It's on the motherboard.
Yeah.
Or it could be a radio, a wireless radio with an address, a NIC, a wireless NIC. Maybe a default gateway if you want to go any place other than the network that you're on. And that's where the router would come in, right? If we do that, so we got to get an address. A lot of things we got to do. And if you go out to some place like Starbucks, you might want to not let other people on your computer. And that's where the network type definitions come in. Yes?
Yeah, and I want to ask you about that because I noticed that my home computer says work group.
Yes.
Okay, and I went to change it, but it wouldn't take me to the place to change it. Well, should I leave it work group or should I do it?
Work group. Okay, now two different things here. Work group, and I think that they make an implication in that other chapter that's not true. It says if it's a standalone, it's a standalone computer, right?
Yeah.
And then you have work group computers, right? You either got to be a work group or a domain. Those are the only two network topologies that Windows supports. So even if it's the only computer in the world, it's going to be a work group computer.
Okay.
And then if you have a domain and you join it to the domain, it's going to be a domain member computer. So, and we have network types. We've got work networks, home networks, and private or public networks.
Well, what kind of made me nervous was like when I was going over the definitions in the book,
Yeah.
it was talking about how it's mildly secure, but not like.
Those and we'll discuss those a little bit here, but the basic answer is if you're in your own private network, work network or home network, either one are about the same. There's some minor differences. You can't create a home group, for instance, in a work network. You have to be a home network. The public network is designed for when you go to Starbucks with your laptop or when you check into Red Roof Inn and get the free wireless. What it does is has different firewall configurations, and that's part of what looking at the firewall and the different things that this chapter is about, part of what this networking is about. This chapter's networking is about. I'll get it out here in a minute. But what that basically says, if you put it on a public network, you're in public, don't share it, share nothing, and let everybody see nothing.
Like always be that way though?
Well, if you want to, for instance, if you have a couple of computers at home, and you want maybe a remote desktop from one to the other, if you don't allow any traffic through your firewall, zero, how are you ever going to get to the remote desktop on the machine you're trying to get to? If you're on your own private network at home, you're fairly secure. There is no absolute security in any of this stuff. Even if you took your computer, put it in a barrel of cement, and dropped it off the Marianas Trench, there's still a possibility somebody could get it. Not a very good possibility, but there's still a possibility. It's like 7 miles, but you're going a lot deeper than we've ever gone before, haven't we? Aren't we? And they got robots that, I don't know if they'll go that deep, but they'll go pretty deep.
I think they do go that deep.
Yeah. But what are the odds? I mean, the odds are remote, so we say it's fairly secure. Same thing on your private network, Margaret. If you're not on wireless, who can get onto your network?
Well, see, like I'm on wireless.
You're on wireless, so which have you got? Are you on secure? They can't find you. Want to bet?
What is it with everybody messing with the
Well, the wireless, you just don't advertise your SSID, right?
Right.
And you think that that's going to keep people that are really wants to get on from getting on, right?
Right.
It doesn't.
Well,
Just as no, by the way, we'll do that in the wireless class.
all right.
But you're fairly secure in that circumstance because you've taken all those precautions. You have security configured, hopefully WPA2, the encryption protocol, so that other users can't get onto your access point.
Oh yeah. I have
So,
all that.
from that perspective,
If I did it public too, then I would be even extra secure.
on that individual machine you would, but the general consensus is, you don't have to go that secure. Would it be more secure? Absolutely.
Is there a way to change your group?
Oh yeah, you'll do that. You'll do that in these activities. How's that?
Okay, good.
Stimulate some interest with it. Yeah, it's a pretty straightforward process to do that. Understand the Windows 7 network architecture, we kind of already did that, didn't we?
Yeah.
Work group and domain. And what's the difference between a work group and a domain environment? What's a work group environment? Where is the security? Where are the passwords stored? We'll get back to that 3-letter abbreviation again, and nobody wants to tell me. SAM. Hey, we're getting it. The Security Accounts Manager, which is a hidden portion of the registry. If we wanted a number of users, the same user, to be able to connect to a number of computers in a work group, you would have to make that same user pass through authentication, the same user, the same password on all those machines, which doesn't sound like a big deal until you get 15 or 20 users, and now you want everybody to change their password. Then everybody's got to change their password on all of the machines that you have access to. Domain environment, centralized management, a centralized database that in Windows is called Active Directory. And that's what we use here, because you can go any place in the building and log on, right, as yourself. If we made you a user on an individual machine, a local machine, then you'd have to log on to that machine every day. So that's the architecture there, I think. Describe and configure IPv4. That one is the click-through. You've already done that. Right-click. You know you need an address. You need a mask. You need a gateway. To get the address automatically, you tell it to get it automatically, a DHCP server. You need a DNS server if you're going to use anything other than IP addresses. Do you need a DNS server? If you're going to do anything other than use IP addresses, yes. If you know all the IP addresses, then you probably don't need it, huh? That's not, we'll get into that some in server. That's not entirely true, oh, by the way. Because when you get into web pages, you may have multiple web pages, multiple addresses running on the same server, and they use a thing called host headers. So just because you got to the IP address doesn't necessarily mean that you can get to that web page. Describe and configure IPv6, very quick. And the thing that I have seen predominantly on testing right now is when they ask you IPv6 questions, they want you to be able to recognize what a valid IPv6 address looks like. That's about how far the U.S. is on implementation. Most of the devices support it, and if you do an IP config on your machines, golly, you've got an IPv6 address. An interesting thing that, and if you've got multiple machines at home and you're using NetBIOS, ping one of your other computers if they're all Windows 7 and above and see if it uses IPv4 or IPv6. It will use IPv6 if possible. Ping an IPv4 address, obviously you can do that. And you can specify which protocol you want in the ping command, either 4 or 6. when you're doing that. To me, the IPv6, it's really a pain. You ever try to ping an IPv6 address? I mean, you got to write that thing down. It's a lot harder than writing 10.60.211.1. You got this big long address. Kind of painful. Perform and monitor file sharing. We've talked about that a little bit. Monitor file sharing is in the computer management. In the shares, you can see who's actually connected to your shares. You can see what the shares are there also. A big advantage to that is if you've got 20 or 30 of them on a machine and you forgot exactly where it is, you know what the share name is because you can find that, but you forgot where it is, you can go look and find the path in that area. Connect Windows 7 to the Internet. That's not a big deal, is it? You got to have a path to the Internet, and it'll usually find itself. It actually is a pretty smart system. Describe and configure wireless networking. You're not really going to be able to configure wireless on a virtual machine because we don't have wireless on a virtual machine. However, you probably can do some of it on these machines because those little blue lights sitting on top of all your computers there, that's the wireless NIC. Because this is where we do the wireless course. So you can look at some of that stuff, or if you don't do it at home, look at it. It's kind of, a lot of it you probably already have done, will do, but just take a look, and that's mostly for you. Configure the Windows firewall, and they're going to take you into the advanced Windows firewall. The firewall that now comes in Windows is fairly sophisticated. It allows you to do configuration down to the port level, in and out. And firewalls, remember, can be used to protect you, both somebody coming into your network and you going out if you've been attacked. Network bridging, describe that. Ad hoc and home group networks, and this is the one that you'll have to change the network on, Margaret. To be a home group, I think I probably had you guys, I think I told you to make yourselves work networks initially. Well, guess what? You can't do a home group in a work network. So you'll have to change it to a home network in order to do that, because I'm going to have you join my home group so that you can do that. If you haven't used home group and you have multiple machines at home, it's pretty slick, I guess, is my technical term. We were talking about technical terms earlier. But, It's very easy to set up. You just put in a password. It's very easy to join. You just put in the password if you're on that network. What it allows you to do, instead of, if you have something that you may use on multiple machines, documents, for instance, and you use one location or the other, you have them instantly or appear to be on your network. You can share them as read-only or as edit, however you want to do it. But when you share a folder to the home group, and you don't share it to individuals, we talked about sharing. We put usernames in to control that. In the home group, you share it to the home group. To get on the home group, you got to have the password for the home group. It is pretty good. The Network and Sharing Center is a central point for managing configuration, and if you want to change the network type, oh, by the way, that's where you go, is the Network and Sharing Center. You just click on whichever one it is and then select what you want it to be. Areas, a network map, active network details, and change your network settings are all in this area. The network map gives you, what it basically tells you is what you're connected to and what's connected to you, what's directly in this area. Change the network settings. You can go into there, change your IP address, how you get an IP address, DNS servers, those sorts of things are in there. So when we go into here, into connections, notice up here it says home network. If I wanted to change it to something else, I should be able to click on home network and select either public or work network here. And the connections and multiple networks connected to the Internet. Occasionally on these machines you'll get the big red X here, connected to the Internet, which means that we're not getting to the Internet until Windows 7 decides that it has actually gotten there, and then it will show the connection to you. Network location awareness, configure the security settings for each location type differently. These are the ones we talk about, the work network, the home network, and the public network. Generally speaking, the work network and the home network have the same configurations. The public network has a much more restrictive configuration, and that's the one, again, that you want to pick. When you go to Starbucks or you go to McDonald's or you check in at the Red Roof Inn or the whoever else that provides you all of this unsecure connectivity. And I'll take a step back. As an oh, by the way, unless you're using an HTTPS site, who can see everything that you're sending on that unsecure wireless? Everybody that's connected to that one. So that's just be aware of what's going on there, because all that traffic can be intercepted. One of the favorites now is somebody goes into this, because everybody's using their cards to buy stuff online and so on, checking their bank accounts, is to go in and do that, and they become the wireless access point. They become a man in the middle, so they connect to the wireless, you connect to them, and then they capture your traffic and go through you and out their wireless card, the wireless wide area network, or WAN card, so that all the traffic goes through them. Each location are saved the configurations, and you can change these configurations. And when you're doing the firewall configuration in these, just look and see what the controls actually are, so you have an idea of the differences between these things. I think you're going to find the only one that really is radically different is the public network. You all manage connections to your computer that your computer has connected to in the network management. Who's connected, who you're connected to, what network are you actually on. And this is the home, work, and public, and you can read what these say. Again, the home network and the work network are basically the same network. A few differences. The big difference is that when you have to do a home group, you have to be a home network. When you, it's not listed here, when you join a computer to a domain, it becomes a domain network. You don't have any real choice here. You just can't go select it. You either join it to the domain or you unjoin it from the domain. You have to have the authority to do that, to put a system on the domain. Network discovery, an easy way to control how your computer views other computers on the network. Network discovery, let's say NetBIOS. So what you basically do is turn network discovery on, network discovery off. What that says is, do you want other people to be able to discover you or not? Private networks, you probably don't want other users to be able to discover you. If you're at McDonald's, do you want everybody to be able to see your machine? This is one of the out of sight, out of mind sort of things when you do these things. Advertises the presence on the network. Advertises the presence, and network discovery, honestly think of in terms of NetBIOS, where you can just use the computer name without the fully qualified domain name. Two different ways of addressing these things, right? NetBIOS, one name, single name, one name lookup, fully qualified domain name, which has the domain, the computer and the domain attached to it. Turn on network discovery, turn off network discovery, and this is one of the things that's going to change when you go from work to public to home. The home network, the public network is going to turn off network discovery so that people can't see your machine by just trying to get there. Connections created to manage the network for each one. Yes, we do all of that stuff. Clients and services that use the network to communicate. The client allows you to connect to a particular service running on a remote computer, and some of these things are necessary. Remote calls are sometimes required in order to make applications work, and there's a service that allows that. Again, this all goes back to the configurations, grouped configurations, home, work, and public networks. What are you going to allow and what are you not going to allow? Do you want your computer to accept connections? Again, on the public network, probably not. On the home network and on the work network, probably not as much of an issue unless you're really worried, as Margaret was talking about, somebody connecting to you. If you're living in a house someplace, probably not a big deal, is it? Apartment building may be more of an issue, because how many public unsecured networks do you see running around in apartment buildings? There are multiples. And just driving up down streets sometimes. We had a guy that was doing a security class, drove down Williamson Road and ran a piece of software to see how many open wirelesses there were. He even got connected to one while we stopped at a red light. So, are they out there? Yeah. Are they dangerous? Yeah. When you're connected to them, are you exposed? You can minimize your exposure by configuring your machine when you're on those networks to be to the public instead of to the home or the work.
How far is the range that someone has to be in to connect to the wire?
That is something that is anywhere from 10 feet to 100 meters or more, depending on the antenna.
Depending on what you buy from the store. I mean, you get...
Can be several miles. There is a story I read of a guy in Colorado that wanted to be able to see his wireless network from his favorite bar. It was about 20 miles away. And he could see his network from his favorite bar.
No interference between him and...
Oh, no, he just made the power go high enough.
Oh, dang, never mind.
He just drove the power. He was violating the FCC regulations. The problem was he could see it, but he couldn't connect because his wireless access point had that much power, but his computer didn't. So there's so many variables in that. We got atmospherics. We got how many walls are between. What kind of walls are they? What's the material? What materials are there? There's a thing called a Faraday cage. If you're really worried about it, put a Faraday cage around your house. Faraday cage is basically chicken wire. It's about the right size.
I would guess though, just the average little router, it's not going to go.
I think that they advertise about 100 meters. I'll pick on Everett since he works over there with those things.
Man, I'm just thinking because farm.
And he's staring at me.
Next house is a little way.
The 100 meters that they talk about is open space, and you get to some places, some houses. I have some people put in one time, and they had it in a bedroom at one end of the house. It wouldn't go to the basement; it was in the center of the house because of the materials that were in the house. So there are tons and tons and tons of that's another good technical term. There are a lot of elements that determine how far these things will actually go. Yep. And what's the signal strength? How many bars?
I've never even paid attention to.
Yeah, you can sometimes you can get a signal. Yeah, you probably could get connected. If you get like one, you can connect at about 2 megabits per second.
I would never do that, and he's like really freaky. I think he works for the FBI, so I think his is locked down.
Oh, don't go there then.
Yeah. So I think he actually has his on lockdown, but I've seen his when I got my menu up, and I'm like, oh well. Yeah,
they're out there. Just because they're there doesn't necessarily mean you can. That's where we get into what kind of security you have configured. Is it an open access point? Do you have the good security? If you have WEP, you can crack WEP in, I don't know, maybe 5 or 10 minutes to do those things. You've done this before, and these things down here, linked layer topology, discovery map, and link layer topology, discovery responder, are things that really are related to V6. And you can turn on or off IPv6. The machines themselves internally tend to use the IPv6 addressing. It's more efficient. Even if you only see the IPv4 addresses, it internally will attempt to use IPv6. Client from Microsoft, and these are things that are quality of service packet scheduler, something that you may or may not. Quality of service allows you to assign priorities to different packet types. And I think that the header activity that some of you did in networking 2, I guess it was, talked about quality of service. What does it do for you? It allows you to assign certain priorities. For instance, voice over IP, the telephone system, you're probably going to assign that pretty high priority because the quickest way to get in trouble is to have the phones quit. Those kinds of things. You can use those. Microsoft file and print sharing, SMB, and you probably have heard me talk about SMB connections. When you go down to that, what used to be run line is type // computer name, server name, / share name, you're using the SMB protocol. When you type // it tries to use the HTTP protocol. So a little difference there, which slashes you use can dictate what kind of protocol you're going to use here. Protocols we've talked about before, rules for communication. Protocols supported by Windows 7, IPv4, v6, both are supported. And if you go back to XP, you can add IPv6 support in XP if you're still running XP and you need to do version 6. IPv6 is the protocol that we're going to imminently shift to for about the past 8 years. We're going to have to go there next month. Next month? Yeah, for about the last 8 years. All of the IPv6 addresses have been assigned. That means that if you go to buy a new one, there's not any. IPv4, yeah. IPv4, there aren't any more new ones available. Are there still unused addresses? Yes. There's a lot of organizations that were on the front end of the Internet got very large allocations of IPv4 addresses. There are things like, though, that at one time they had one Class C subnet assigned to Africa, the whole continent. So some parts of the world have transitioned to version 6, mostly because they had to, Asia predominantly. But we're still on IPv4. All of those things that we talked about, NAT, proxy servers, those kinds of things, have preserved version 4 addresses, private IP addresses, and out of the public addresses. So how many addresses do you really need to run a big network? One? Once you NAT to the public address, that's the only one you need, isn't it? Because it gives you a socket. It gives you that IP address, and everybody gets a different port number. So everybody has a different socket when we do those things. And the drivers, we talked about drivers. Interfaces, to make it easier for developers to create clients. The interfaces, the API, the Application Programming Interface, is a standard, and I think about it as a point that you connect your application to, whatever it is. It's a standard connection point for the operating system. Client servers. This is when Windows 2000 started. Game writers, gaming programmers hated because at that point you no longer had direct access to the hardware. They loved to write the programs, the cards, the video for the hardware itself. Windows kind of stopped that with 2000 and didn't give the programs direct access to hardware. Keeps you from tying the system up, from crashing the system so much. But the interfaces are what allow that to happen. The Win, SOC, those interfaces, these interfaces we're talking about, I got to get back where we are in the network architecture. That's the operating system interfaces. The WinSock, the Windows sockets in user mode, TDI, kernel, the WinSock kernel. Again, kernel is the core of the operating system, and the NDIS, the network driver interfaces. These are all things that are available. In the certification process, what they'll probably ask you is what is NDIS, and what that allows you is to have multiple protocols. Because it would be handy if we'd be able to do this. How all of these things connect, the TCP/IP sys, all of these things go through something else. The NDIS is down at the hardware layer. And the NDIS allows you to have multiple protocols connected to the same hardware set. IPv4, been there, done that? What's WINS? The what? Driver interface. What's Wins? What's Wins? Windows Internet Naming Service. That's a NetBIOS name server. So I picked out the one that we really didn't talk a whole lot about, right? Everybody got the rest of them, right? IP address, no problem. Subnet mask, no problem. Create 14 subnets, no problem. Default gateways, no problems. DNS, no problems. Wins, what the heck is that? Windows Internet Naming Service. If you use Wireshark, it'll show up, the letters will show up as NBNS, NetBIOS name server. That's what that is. What that allows you to do is to use NetBIOS. Windows doesn't need NetBIOS. Some applications do. How do you find out? And this is according to me. How do you find out if the application needs NetBIOS? Turn NetBIOS off. If it works, no problem. If it doesn't work, turn it back on. That's maybe not a real great way to do that, but that's what services do you need? Turn it off. If it doesn't affect anything, leave it off. If it affects something, turn it back on. Until you disable it, if you turn it off and it breaks it, when you restart the machine, it'll start back up, because that's the way services do. They start automatically unless you tell it not to or disable it. So, don't try, when you get into troubleshooting and those kinds of things, don't try to overcomplicate things. One step at a time. Basic. I mean, can't connect, and you guys have been here, can't log on because there's no logon server available. What's the first step? What's the most basic step? The cable. If I'm the only one that it's happening to, probably pretty well isolated, right? See, this is like our non-technical brethren who everybody else in the world logs onto the server, but they forgot their password, right? Probably not it. Dotted decimal, we've done all that things. Proxy server, what does a proxy server do for you? You use a proxy server every day because that's how you get to the internet. What a proxy server does is takes your internet request, rebuilds it, and sends it to the internet. So when you go onto the internet from here, your machine doesn't go on the internet. The proxy server goes on the internet. That is one more system that allows us to use a single public address for the entire network. Because we can use private addresses, send that to the proxy server. The proxy server then goes out with the public address to get the information, comes back. When it gets the information back, it sends your request to you. NAT, we talked about in networking, right? Network address translation. What's the difference between NAT and PAT? The reason I ask these questions, some of these things get a little some vendors want you to know the difference, some don't really care. Network address translation, true NAT is a one-to-one private to public address translation.
Is mine automatically like a proxy? Because mine...
Yours is a PAT, port address translation, because you probably, like me, buy one public address, right? And you can go to the internet with multiple computers, right? What you get is, and they'll call it NAT, but it's really PAT because you only have one address. Port address translation. Your address is hidden because of your router, because you get a port address translation. It translates your public address, your private address to a public address, whatever public address that Verizon or Cox or whoever assigns to.
So anybody that's trying to get to me,
it's got to
get Verizon.
They're going to get to the Verizon, and that's why NAT is a great firewall, and that's what a lot of the firewall of the routers are, because, yes, they can see your public address, your Verizon address, and they get to the router, and now where do you go? Because they don't have no clue what the private address is, so they can't go any further. That's how NAT protects you. Connecting to the wireless. See, when you do wireless, there's a couple things. Can you get in through the TCP/IP channel or through the wireless channel? There's two vectors of attack there. Whereas if you're wired, change what? What would you change?
To that instead.
So you already that the routers that we buy are automatically set up for that.
So mine's automatically.
It's automatically going to do an address. It's automatically going to do an address translation.
Already have that.
Yeah, but well, how are you going to hide your public one? Use a proxy server and really get slow, and get even slower. You can use multiple proxy servers. Why you want to hide your public address?
Military uses it all the time.
Military uses it all the time, kind of. You could buy multiple addresses and just, have a random selection there for that, and it just seems kind of expensive. The other question you got to ask from a security standpoint, do you have anything that's worthwhile for somebody to go that much trouble?
No.
I certainly don't.
I have things.
I bet Bank of America does. I bet the Federal Reserve does, but I don't.
I've never used my credit.
Would somebody, credit cards are, I heard the credit card thing. Credit card's a lot more secure on the internet than it is when you hand it to the waitress at the restaurant. Because, it doesn't bother you to go to a restaurant and hand your credit card to a perfect stranger that goes out of sight to do something, right? But you have an encrypted connection on the internet, and you're afraid to use it.
I'll dispute charges all day long. I don't care.
You can dispute them, but it doesn't bother you to do that, right? We do that all the time. But it bothers me too. But people say, "Oh, I'm scared to use it on the internet." What you don't want to do is allow them to store it on the internet, because that's Amazon's favorite trick is. Check here so that the next time you can have one-click shopping, right?
Yeah.
What does that mean? That means that they have your credit card on record in a database, so when the database gets hacked, they can steal your credit card. What if your credit card isn't there? And they can't steal it. So, those are some things to be aware of as you go through these things. Is it secure when you send it across the internet? Yeah, because it's encrypted. The thing we talked about, the encryption, how does the encryption algorithm work? We'll go to an HTTPS site. It sends you its public certificate. Your computer creates a session key that you're going to use for that encryption, encrypts it with the public key for the server, sends it back to the server, is decrypted with a private key that's on the server. That's why private keys are a really big deal. If they get compromised, then it's no good. And then you use the key that you created to encrypt all the communications. When that session's over, you close the browser, because if you ever noticed that sometime at a bank when you log off, it says to complete closing this connection, close your browser. When you close the browser, it destroys that key. If you go to an HTTPS site, again, you go through the same process, create a new key. So that when people go out and get these keys, we've cracked this protocol, this encryption, this protocol on the internet, they have a session key. Won't work next time because you got a new key.
But even though, what if your bank, is a financial institution, they'll do a session timeout?
Yes, they'll do a session timeout. That's.
You don't even have to worry about closing the browser then, right?
Yeah. I would always close the browser because it's cached until you close it. You see things, and one of the configurations, while we're talking about security, one of the configurations, and I'm not sure if it's the default, that you should do on your browser, particularly Internet Explorer, is to delete all the temp files when you close the browser. And that's where you get into this, is it a temp file? Because a lot of viruses mingle around, hang around as a temp file, and we see that a lot when the antivirus software hits. That it'll show up as a virus on the machine, you go to the machine and it's not there. Probably was a temp file, and when you close the browser, the temp file got destroyed. So those are little things you can do to make yourself a little more secure. And you do a lot of little things, then you've increased your security significantly. The thing that you really want to do with security is make yourself more secure than the next guy. It's the old story, and when you have security, you'll have to listen to it again. Two guys are out in the woods, and they come across a bear, and one turns to the other and says, "We got to outrun that bear," and the other one says, "I just got to outrun you." That's the way security is.
That's where the saying, two went in the woods and only one came out.
That's right. That's what security is. If you were going to steal a 60-inch flat screen television and you knew where two houses where they were, would you go into the one with the Dobermans or the one with the door open? Security's the same way. A lot of people left the door open. Don't do that. The private ranges I went over, the IP, the subnet masks, we've done all that. Default gateways, a default gateway by any name is still the router. And the next hop is still the default gateway, right? Routers don't have default gateways, they have next hops. Same thing. That's where you're going to. DNS, domain name system, domain name service, you'll see it probably both ways. Takes the name and turns it into an IP address so that we don't have to memorize all those IP addresses. That goes back to when years ago they were somebody had written a virus to attack the White House website, whitehouse.gov, not whitehouse.com. But they put the IP address in the script to attack it instead of the fully qualified domain name. So how do you fix that? Just change the IP address in DNS. And then when it attacks some address that has nothing on it. Learn how to use the system to your advantage, what works and what doesn't work. You guys probably like typing Moodle here instead of like roanoke.ecpi.net, right? You can do that to yourself at home. Thing I was telling you about the one woman in a class of guys that were really harassing her, and somebody left his machine open, so she got on and changed his host file to where it resolved espn.com to barbie.com. All you got to do is go in and ping roanoke.ecpi.net at home and find out what the address is. It's 199 something. And then go into your host file and type 199.something space. Got to have at least one space in the host file, Moodle, and then clear your DNS cache, probably. ipconfig / flush DNS, right? And then when you want to go to Moodle, just type HTTP Moodle. And you don't have to type roanoke.ecpi.net all the time. But you have to do the configuration. Make the systems work for you. Don't work for them. WIN's the one I asked you about. Windows Internet Naming Service is a NetBIOS name server. NetBIOS traffic goes way back to networking. How far does NetBIOS go? Everybody looking at me really funny. We're going to have to go back and redo that class, right?
Back when they was using chisel and stone.
Back when they were using chisel and stone. Actually, some things have used NetBIOS for recently. You probably have used NetBIOS recently. You ever get that message on your virtual machines that says that there's a duplicate name on the network? You should have in the XP machines because they have NetBIOS enabled. NetBIOS goes all the way to the router. It's a non-routable protocol. So if we wanted to go past the router, we would use a WINS server, which is, for lack of a better description, DNS for NetBIOS. Does the same thing for NetBIOS names that DNS does for fully qualified domain names. Methods of configuring, static, dynamic, a PIPA. What's a PIPA? I know that one. It's what? Gives you an IP address, gives you a 169.254.something.something with a 255.255 and no default gateway. What that tells you as a networker is that my machine is configured for a dynamic address, a DHCP address, but it can't find a DHCP server. So Windows gave me an address. A 169.254 is actually an address range that Microsoft owns. A PIPA, an alternate IP configuration, and they have an activity for you to do that. It's something that is there you need to know about, in my humble opinion, which is worth nothing unless you take $1.50 to McDonald's, and with that, in my opinion, you can get a cup of coffee.
That's pretty good.
Well, what this is if you have, and they always say, you got a laptop that you take home and you use at work. Well, when you take it home, you don't have a DHCP server, so you have an alternate configuration. And you take it to work, you have a DHCP server. It gets a dynamic address. What the alternate IP configuration is you really actually change the APIPA address. Instead of getting a 169.254, you get whatever address you set in there. And you can assign them with scripts. Anything that we can do at the command line, and we can assign all this stuff at the command line using the net shell command. You can script. DHCP, we've done all of that, right? 169.254, see, we've already done all these slides. Configure to static. Hazard for static is, nobody ever makes a typo, do they? Automatic private. See, this is the alternate configuration. The default is APIPA, which is the 169.254. The user configured, you put in your own address. So all you really do is, in the alternate configuration, is change it from the APIPA address to one that, an APIPA address, automatic private IP address that you configure. Hostname command displays the host name, and these are different things there. ipconfig, that is a command that you really need to, if you haven't, look at all of the options. That's a command that you're going to use throughout your career in, at least Windows career for the time being, IT career frequently. What's going on? What's the address? What's the mask? What's the DNS server? Things that can't resolve. Well, I can ping IP addresses, but I can't ping fully qualified domain names. Well, DNS server, right? I can ping host names, but I can't ping FQDNs. The other way around. I can't ping the host name. Is there a Wins server if it's off of your network? And back to the other configurations is actually turned on. All those things on and off. Ping command, been there, done that. Ping is probably one of the handiest commands that you use. Problem is when people tell the other end to not respond to ping. Traceroute. When you use traceroute, where it fails is where the problem is. Because it does, how does it work? How does it traceroute work? Anybody ever thought about that one? It goes to router. It depends upon the TCP configuration. What happens when you get to the last hop? What happens to the packet when you get to the last hop? Because we have a TTL built into IPv4, right? And that's why we don't have 10 bazillion packets running around on the internet that are lost. Time to die. Traceroute, time to live, time to die, same kind of the same thing. TTL, time to live. So what traceroute does is set the TTL to 1. And when it gets to the first router and it decrements it by 1 and it gets to 0, what does it do? It dies and it sends an error, an ICMP error message back. Okay, I got there. Then it does a TTL of 2. First router, second router, dies, sends the error message back. TTL of 2, that's why it's so slow, because it has to go through a big process. But when it gets to something that won't respond or it can't get there, you don't get the error message. That's where the problem is. And when it gets to the end, it says, oh, I have arrived, right? You have arrived at your destination. Path ping is kind of Microsoft's version of traceroute. It gives you a little bit more statistics. It's an interesting one to look at. To me, it takes longer than traceroute, but gives you a little bit better analysis of what's going on in the path itself. The route command displays the IP routing table on the machine. So you can do that. You can put manual routes into your machine if you want to. You can put persistent routes in it. The netstat command, the different types of statistics, these are all commands that you probably looked at. You keep looking at them, what's going on, what's going on, what's going on. Netstat, the different types of TCP statistics for active software connections. This is one that's kind of handy to look at home. Who's connected to me and whom I connected to at any point in time. Netstat-all or /all. what connections are there. Both TCP and UDP will show up. NBT stat, we're talking NetBIOS here when you're looking at the NBT stat command. Getmac gets the MAC address that you can find that. ARP command, what does the ARP command do? Address resolution protocol, so that's the one that we resolve the IP address to the MAC address. That will give you a listing in your cache of the MAC to IP addresses. Can be handy if you, for whatever reason, you're not getting somewhere and say, well, IP addressing is correct. You may look at that and say, oh yeah, but it's going to the wrong MAC address. Some of those things happen. The, I guess, most interesting one that I had, and it was my fault, we were using some virtual machines in another room and we copied them. And when we copied them, we didn't tell it that we had moved them, so they all wound up with the same MAC address. And if you want to see a troubleshooting problem that is like, sometimes it would work, sometimes we could ping, sometimes we couldn't ping. To finally look at the ARP and say, hey, all these IP addresses have the same MAC address. Now I have a real issue, because you can change the IP address and not change the MAC address. The netshell command is a scripting tool. The netshell command is the one that you would set at the command line, the IP address, the default gateway, the subnet mask, and all those other things. NS lookup is the mystery command for everybody. I've got a little video on NS lookup. What NS lookup does is allows you to mimic DNS on your desktop with the NS lookup command. You set the type record that you want to look up, and you're really confirming that DNS is working properly, is what it's all about. I say it's the mystery command because I ask the same question on about 4 different tests and people miss it on the same question on 4 different courses on 4 different tests, or 5 or 6 different tests. NS lookup. What is the something like what's the IP address of the Google email servers? So now you know what the question is. I got to just find the answer. It's easy to do. What kind of a record does an email server have? You guys add Linux. Oh, you didn't do that part yet. It's an MX record, so you just got to find the MX record for Google.com or Gmail.com. So that would be it. All of those utilities, most of those utilities, you obviously have used before. IPv6, increased address space. One of the big differences between 4 and 6, other than the address space, the length of the address, hexadecimal versus decimal that we use for the addressing space, it does have a simpler, bigger but simpler header information, extensibility to support new features, encryption services for data security. IPv6 by default is secure. IPv4 by default is insecure. So in order to make IPv4 secure, we do this VPN stuff, IPsec configurations. And I think they've got an activity they have an activity in there that emulates, simulates, does an IPsec connection from the firewall itself. The address space is not nearing completion, is depleted. Again, does that mean that there are no unused addresses? No, there are unused addresses, but there aren't any new ones for sale. I may have said here in at least one of the classes, Microsoft just bought a company just to get their IP addresses, their IPv4 addresses. So they are available. I was doing a course. The instructor said that he was doing a course someplace, in, I think it was University of Iowa. Somebody from IT said, oh, we've got a Class B address space that we don't use.
Nice.
That's a lot of addresses. And with NAT, we could really make that go a long way. So there are addresses out there, there just aren't any new, and there aren't any new addresses. 128 bits, more addresses, and all sorts of, anybody ever look that number up? It's just really big. You hear things like more addresses than there are grains of sand in the world, things like that. But are we going to run out? Not in my lifetime, and probably not in yours. But I'm sure that when they did IPv4, they didn't think they were going to run out of those either. How many addresses have? Now they're putting internet, what is it? They're putting the internet, I suppose a Mercedes commercial says, your phone's got internet, why don't you your car? So now they're putting internet connections in the cars too. And you got to have some of that stuff for all of the communication back and forth. You got to have some way to get there.
You know why they went straight from 4 to 6?
Yeah.
You gonna tell us?
No, he'll tell you at the break. Because Chuck Norris doesn't like 5, right?
Yeah, Chuck Norris doesn't like number 5.
Was there anything before 4? Ah, there's a research question.
Yeah, it's just like phone. There's 4 numbers instead of.
I think that's the answer. Link local is in DOS. There were some that you never see that were withdrawn. DOS version 4, MS-DOS version 4 was so bad they just took it back. So some of them, when you look at the history, some of the things existed and some of the things didn't exist. The IP address, the link local, computers on the local network, and those are the ones that you'll see on the machines that you have. If you do an IP config, you'll see an FE, I think it's FE80, something. Link local address. Global Unicast can be routed as public addresses, and these are just new terms for private addresses and public addresses. I said that about, well, that's a bad way to say it, because there are no private addresses in IPv6. That's one of the things that people love to hate, is there's no NAT, so you can't conceal your addressing scheme. You can do random assignment because there's so many of them. Routers take care of a lot of this, and IPv6 does a lot of its own configuration. It is available. They're trying to get to it. Unique local Unicast, deprecated site local address, and the reason I say they have changed these names a number of times, and they've changed which addresses they're going to use and which addresses they're not going to use. So I don't know that the RFC is actually set in stone yet. Multicast, Anycast, really great names, right? Special addresses, just like we have in IPv4. The loopback address. The loopback address, the only one that's easy is : 1. You don't have to type 127.0.0.1. Teredo allows IPv6 to be tunneled over an IPv4 network. What that says is if you've got an IPv6 network and you've got IPv4 connectivity, you put an IPv4, boy, this is a lot of terms, a lot of 4s and 5s, 4s and 6s. You put a 4 header on it and send it to the 6 network. The 4 header gets stripped off and it uses the 6 networking at the destination. And generally when we talk about tunneling, we draw these really cool tunnels that goes directly from one to the other. And when you think about that, how many routers, if we did a tunnel from here to Virginia Beach, which we do, how many routers do you think are between here and there? More than one. So what you have to have is a header on the outside that the routers understand, because they don't understand your encryption. That's what tunneling is about. It's an encrypted packet that goes from one to the other. It automatically is going to configure these things, but you can have statics, automatics, and scripts, same thing as we had before. Except the only thing we're missing here is the APIPA address, isn't it? Because you really don't need that. The routers generally can be configured to allow the machines to automatically configure the addressing. And with dynamic DNS, we can automatically put those into DNS. The connectivity is the same troubleshooting that you use in IPv4 is basically there. I've been going long enough for a while. Let's take a break and then we'll do the file sharing and the firewall.
Or in a work environment, you need to.
Sometimes why we want to share files, because sometimes you need to Exchange information. Why do you guys do all this social networking? Because you know, you as an age group, except for me, do social networking generally, right? Why do you do that? So it's fun, but what are you doing when you do that? Sharing information. Now let's put you in a work environment, and you have a project to do. How are you going to share the information? You don't? So you're going to do all the work yourself and let everybody else take credit for it.
It's easier to share folders.
It's either share folders so we can do file sharing, and in fact, that's a misnomer because you cannot share a file. You can only share folders. You share the files within that folder. I call it file sharing, though. But what we're really doing is folder sharing, and we're sharing the resources that are in that folder. How do you share these resources? We did that one earlier. How do you share something? Huh? Permissions. How do you do that?
In your permissions tab.
You're getting way too. How do you do that?
How do you write down the
How do you share something? What's step one?
You have to assign it to.
I would say right-click on the folder
Yeah.
and click sharing. Right? That's all I want. That's all I wanted. I don't want to get too complex into permissions. That's something else. But this one is in fact just sharing what's shared, who's looking at the shares. Allows you to share files from any folder on your computer or the public folder. And the public folder you can share, obviously, let everybody see it, with other computer users on your LAN. And we looked at a couple of different ways to share resources. One was the standard sharing, that the new way of sharing, and the advanced sharing. And me being really old-fashioned with a fragile mind, still like the advanced file sharing because it's the old-fashioned way of doing it. The public folder, you can share things by putting them in the public folder and allowing users to see that. Turn on sharing in the public folder. You turn sharing on, turn sharing off, and when you put things in, they are shared on your network. And this is where you would get advanced sharing options. Turn on network discovery. Turn on the file and network sharing, or printer and file and printer sharing if you want to share printers. And then the public folder sharing is down at the bottom if you want to share your public folder. And remember, the public folder is part of the public profile. That's the one that you use to put that shortcut from Notepad onto the desktop for everybody, right? Some of you are shaking your head yes. Some of you are staring at me like I'm from Mars. Trust me, that's where you're supposed to do that one. Password protected sharing related to the public folder. You can turn on the password protect. And what we're really getting to here is about what we used to have in Windows 95. You could share stuff in Windows 95, but it wasn't based on the individual. It was a share, and the share had a password, not the individual had a password. NTFS, authentication, then we can get into the shares, not the public shares. So you can turn on or off those. Any folders, say we've looked at that in the previous chapter, I think. Right-click, set permissions, who can use it, who cannot use it. If I gave it to Josh and not Maurice, we would have implicit denies because I gave it to Josh and didn't give it to Maurice. Josh could get on it, but Maurice couldn't. Explicit denies is when you check the no access, and if you use that, please use that sparingly because the only way to get out of that was to go back and uncheck the no access. And as I said before, you'll probably remember tomorrow and maybe next week, but probably not next month, and I can guarantee you won't remember in 2 years why they're now denied. So implicit denies are much easier. Group assignments simplifies that even more, so that if you had a resource that you wanted to give 1 or 2 or 3 or 4 or 100 users access to, create a group, give the group access to it, and then put the users in the group so that they can then inherit the permissions of the group itself. Domain-based, work group-based, local accounts are in the domain-based. We're going to share it to the domain accounts, and the local, the work group obviously to the work group users on that machine, the local users on that machine. The home group here, if you have a home group, you can share it to nobody, the home group read write, or specific people. If you're in a work group environment, which most of us are at home, this really is the simplest way to share it throughout the home network. And when you do the network types, the work, home, or public, you got to be a home network before you can create or join a home network or a home group. It works very well. You just go into, and I'm not going to go through these things, but you share it. You go into the control panel and either create it or join it. If there is already a home group on that network, you'll join a home group. All you have to have is the password, and I think there's an activity to do that, and there should be a home group on your network with the password. You'll never guess, capital P, password 1, so that you can join that home group, just to go through the process. The advanced sharing, we looked at that a little earlier, didn't we, with the when we did the permissions folder, share with interface, advanced sharing, share with who we're going to share this with, and we can then pick specific users. The advanced sharing gives you the same view that you would see in earlier versions of Windows if you just went to the share. Okay, it gives you a list of users that you can do. And the default share is read to everyone. The hazard with that is if you want to share something to yourself and let yourself write back, you've got to give a higher level of control. Before, or Windows 2000 and before, the default share was full control to everyone. What does sharing allow you to do? What does it really do?
File transfer.
File transfer allows you to see it across the network. Share permissions, remember, are only remote. Have nothing to do if you log on at the console, you log on at the computer. That's where the NTFS permissions come in. And this is showing read plus NTFS modify, and since we've already been through that one once, since we're using both of them, we get the most restrictive. And the most restrictive of these is going to be read. So when you access a resource remotely, you get whatever the lowest level is of either your share or your NTFS. Now, if it's shared in more than one place, and it could be, and you have more than one permission, and you could have, on the individual share or NTFS permission, you get the most permissive, the highest level. When you put them together, you get the lowest level. So if you had full control, this one says share and read, we still get read. If we had full control and full control, you get full control. If we had full control and read, or read and